Hello. In this video, we will cover section 9.3, which is on confidence intervals for means. In chapter 7, we use the central limit theorem for proportions to create an interval around a sample proportion where there was a percentage chance of finding the population proportion. This was called a confidence interval for proportions. The process for means is essentially the same with some minor variations. First, we choose the confidence level. This was the exact same thing that we did for proportions. Larger confidence levels go with larger intervals. That's the same as proportions. The interval needs to be larger to be more likely to contain the parameter. Right? So the higher percentage chance you go, the wider the interval you want to make so that you have a greater chance of catching the parameter. This image here is from the proportion section. You notice it says sample proportion. That's because there wasn't an equivalent image for means. But you could go through and just cross off proportion here and say sample mean, and then everything else here would be exactly the same. Once you've selected a confidence level, you need to go through and find the multiplier. This is, again, the same thing that we did with proportions. This is the number of standard errors that we step out from the center to find the outer edge of the confidence interval. Just like with proportions, we use a table to go through and find it. The table is a bit more complicated because we have this degrees of freedom thing, right? So this adds kind of a vertical component to the table. And don't forget the degrees of freedom is one as the sample size minus one. Okay, so this is a portion of a table. I don't want you to think this is the whole table. You'll notice that degrees of freedom go from 28 to 34. You could have degrees of freedom that are less than 28, that are greater than 34. This is just a snippet from a table. Once you've gone through and found the multiple, you can go through and you can calculate the margin of error. So what is the margin of error? It's the multiple, that's the T star. Did I say T star on the previous page? No, I didn't say that. So this is the T star, whatever thing that you find, that's the T star. Okay, and then you take the T star and you multiply it by the standard error estimate. Okay, and T star was what we just found in that table. All right. Finally, we use the sample estimate. Okay, yeah, so once you've done that, you can use the sample estimate mean as the center of the interval, and then you add and subtract the margin of error, which is this thing that you just found. And this should be exactly the same as what you did for proportions, except you're just using a different table here, right? Everything else, there's nothing new here so far, just a different table, and it's going to turn out a different standard error estimate formula. That's going to be the main differences. Okay, so let's put it all together. Here's the completed formula. You've got the mean of the sample, plus or minus the T star, which you looked up in the table, times the standard error estimate, which was given in the last video. It's actually written down here, where X bar is the mean, T star is the thing that we just repeating myself, and then SE is the standard error estimate, which is given by S, which is the standard deviation of the sample over the square root of the sample size. Okay, so this is just a formula, a very similar formula to the one that we used for confidence intervals for proportions. Let's do an example. All right, so suppose we have 35 two-year colleges as a sample, right? So we've got a sample of 35 two-year colleges, has a mean of tuition of 4,173, standard deviation of 2590. It wants us to find a 90% confidence interval and a 95% confidence interval, for all of the two-year colleges. And it says verify. So, okay, first we need to go through, and it tells us to go through and verify that the conditions hold. All right, let's just do that. So how do we tell that this is a random and independent? Well, we look for the word random in the information they gave us. Okay, that's the same thing that we did with proportions. Next, we check the sample size. We look at the sample size. Sample size is 35, so that is 25 or larger, so we're good. And then if you go through and check the big population, if we take 10 times the 35, is that still smaller than the population? Yes, there are definitely more than 350 two-year colleges, in the United States, which I'm presuming this is referring to. Okay. Once you've done that, the next thing we want to do is we want to calculate the degrees of freedom and look up the T star multiple. All right, so that's the thing we're going to do next. So we can use the T star table from a few pages back. First, the degrees of freedom. What is the degrees of freedom? It is the sample size minus 1. So the sample size is 35. So that means the degrees of freedom is 34. All right, now let's look to our table. All right, so 34, that's the degrees of freedom. And we want to find a 90% confidence interval and a 95% confidence interval. So for the 90%, we're going to use 1.691 for the T star. And for a 95%, we're going to use 2.032. Okay. 1.691, 2.032. So we've copied them over. All right, once you've found the T star value from the table, you next need to go through and calculate the standard error estimate. To do that, we're going to take the standard deviation from the sample. All right, this is important. This is from the sample, and put it over the square root of the population size. All right, so what's the standard deviation from the sample? They gave it to us, 2590. They just told us that the standard deviation from the 35 two-year colleges was this. If they had not given this to us, and we instead had known the 35 two-year colleges, we'd had them like in a list, then we need to go through and calculate the standard deviation ourselves. All right, and we're actually going to do that in the next problem. Okay, so, but anyway, we don't need to do that in this problem, so we just put the 2590 there, divide by the square root of the sample size, which is 35, square root of 35, and you get this. So next we're going to go through and we're going to take that result, and we're going to substitute it all into the formula from the previous page. Okay, so the formula says to take the sample mean. What's the sample mean? Again, that was given to us, 4173, right? It has a mean of 4173. So you want to take the sample mean, start with that, and then you're going to add and subtract the T star value you looked up times the standard error estimate value that you got. So we're going to have 4173 plus or minus 1.691 for the 90% confidence interval. That's this value here. That's what we got, the T star for 90%, times the standard error estimate value, which is right there. And then you just go through and just do the math. Okay, and then for the 95%, exact same thing, except we're using the 2.032 instead of the 1.691. Okay. All right, and that's how you go through and calculate a confidence interval. And that should feel very, very familiar. That's essentially the exact same process that we did with proportions, with a slightly different standard error formula, right? And a slightly different table for the T star. Everything else was the same. All right, let's look at a homework example this time. So we've got the weights of 4 randomly chosen bags of horse carrots, each labeled 20 pounds. That's supposed to be pounds, not points. We're 20.5, 19.7, 20.7, and 20 pounds. Assume that the distribution of weights is normal. So they're telling us that the distribution of the original data is normal. And then they say, find a 95% confidence interval for the mean weight of all bags of carrots. Can you reject the statement that the population mean is 20 pounds? Okay, well, we'll look at that at the end. So the first step is to check the conditions of the central limit theorem. All right, so what are those conditions? First, random and independent. Sample is randomly collected. The word right there, randomly. Boom, check. Next, the large sample is met if the distribution is normal. So they told us the distribution is normal. So even though we only have 4, even though our sample size is only 4, we're still good because we're told that the distribution of original weights is normal. Okay, so watch out for that. If the original distribution is normal, then you do not have to have 25, the sample size has be size 25 or larger. And then the big population, well, we're going to presume that if you take, that there's more than 40 bags of carrots. Okay, we're just going to presume that. Otherwise, then we wouldn't get to do the homework problem. All right, so once we've gone through and done that, next we get to the calculating part. So first, we're going to calculate the degrees of freedom and look up the T star multiple. So the degrees of freedom is the sample size minus 1, so it's going to be 3. And then for a 95% confidence interval, the T star. So, okay, how do you look this up? So there's a table on the next page. I know the table is really small, but if you go to degrees of freedom 3, you might not be able to see it. And if you can't see it specifically, you can just Google this. You can Google a T distribution critical value table. But if you can see it, 3 degrees of freedom, 95% confidence interval, 3.182, right? So you're just going through, go to the degrees of freedom, go to the row that has the degrees of freedom that you're interested in, go across until you find the confidence level percentage you're interested in, and then that's your T star value. So in this particular case, 3 degrees of freedom, 95% confidence interval, that's 3.182, right? So that's where that came from. Next, we need to have the mean and standard deviation of the sample. So of the sample, what's the sample? These 4 things, that's the sample. So we need to have the mean and standard deviation of this to go through and use the formula. The formulas, if you go back to the formulas, this is X bar, that's the sample mean. S is the sample standard deviation. So you need to have the mean and standard deviation from the sample to go through and do that. So what I did is I took these 4 pieces of data and I plugged it into StatCrunch. So I'm not going to show that. You know, you can do that. You can use StatCrunch to do that, or you could use some other statistical software. You could just Google a statistical software, you know, to go through and do that calculation for you. It's only 4 pieces of data. It should be very easy to go through and calculate. If you do that, the sample standard deviation, sample mean is 20.225, and the sample standard deviation is this long thing that starts at 0.45. Okay, so once we've got the mean and the standard deviation and the degrees of freedom, we can go through, I guess we don't need the degrees of freedom for the next part, but we can go through and find the standard error estimate. So that's going to be the standard deviation, that's this thing that we just used, over the square root of the sample size. So the sample size was 4, right? And then just plug it in and just you know, plug this into a calculator, and then boom, you've got your value. Okay, so we're writing it out to 8 decimal places, so we, you know, you round at the end. And then finally, you want to take everything, all this stuff that's above, and you want to plug it into this formula. So the X bar, that's the sample mean. That's this number here, 20.225. The T star, that's what we looked up in the table. That's the 3.182. The standard error estimate, that's what we just calculated. Put that in there too. Then go through, multiply, and then add and subtract, and you get your range of values. So the confidence interval is going to go from 19.5, if you round it to 2 decimal places, to 20.95, again, if you round it to 2 decimal places. Okay, so that's our interval. It goes from here to here. This is the bottom end of the interval. This is the top end of the interval. Okay, so the question is, can you reject a population of mean of 20 pounds? Right? Can you go through and say definitively that the population mean is not 20 pounds? And if this is your confidence interval, then no, you can't. Why can't you? Because 20 pounds is in your interval, right? Your interval represents a range of values for where you think that the population mean is. Okay, so again, this all comes down to going through and you're finding samples and you're using those samples to make statements about the population. So we've got a sample of 4 bags of carrots, but presumably there's lots and lots more than that. There's a big population of all the bags of horse carrots, and there's hundreds or thousands of those bags of horse carrots. And what we're trying to do is we're trying to estimate, you know, what the value is for the mean of all those bags. And if this is your 95% confidence interval, you're 95% sure that the mean for all of the bags of carrots is between 19.5 and 20.95, then you certainly cannot say that there's 20 pounds. You can't go through and reject the possibility that the mean is going to be 20 pounds, because 20 pounds is in that range. Okay, so let's see, hamburger chain is selling, so one more example, hamburger chain is selling large hamburgers. We take a random sample of 30 burgers and we weigh them. And we find that the mean is 0.59 pounds and the standard deviation is 0.1 pound. Now it wants us to go through and construct a 95% confidence interval. All right, so the first thing we want to do is check the conditions. Is the sample randomly collected? Random, boom, yes. Do we have a sample size 25 or larger? Yes, we do. So 30 is bigger than 25, so we're good. And then we're going to, oops, I didn't fix the bags of carrots. I just copied this over. So we're going to assume that there's more than 300 hamburgers. Okay. Next, we're going to calculate the stuff. So we start off with the degrees of freedom, and then we look up the T-star multiple. And then we use the T-star table. It's not on the next slide, but it's on the previous one. The degrees of freedom is the sample size -1, so that's going to be 29. And then for a 95% confidence interval, and then I know there's going to be people who absolutely cannot see this, but if you go to 29, there is a row for 29 degrees of freedom, and we're doing a 95% confidence interval, so you're going to get 2.045. Okay, so our T-star value is going to be 2.045. And it's copied right to there. All right, next, once we've done that, we're going to do the standard error estimate. And that's going to be the standard deviation of the sample over the square root of the sample size. The standard deviation for the sample, they gave it to us. They said the standard deviation for the sample is 0.1 pound. So you want to put that 0.1 here in the numerator, divided by the square root of the sample size. The sample size is 30, so square root of 30. Do the math there, and you're going to get this number. All right, then finally, we substitute everything into our final formula here, right? So where X bar is the only thing that we haven't discussed so far, and that is the sample mean. The sample mean, they gave it to us. It's 0.59. So take that 0.59, put it here, add the T-star value times standard error value that we got, and then do the multiplication and then add. Same thing with subtraction, and you get your range here. So it looks like our range goes from, the hamburgers are going to range in weight from 0.5527 to 0.6273. Okay, and there you go. That is all there is to it when it comes to finding means, confidence intervals for means. Basically, the same process as finding confidence intervals for proportions with just a couple small tweaks. Okay, thank you for watching. I'll see you next time.